So each autumn there's a lot of problems on the railway line because of contamination that largely arises from leaf fall. So leaves fall onto the track, they're crushed by the passage of trains and they form a very slippery black layer. This is made worse by the moisture that tends to be prevalent in autumn as well. So this leads to quite a number of braking and traction problems.
Train drivers have to brake lighter and earlier, and that imports delay in more extreme circumstances. Trains can slip, slide through a station, or we get flats on the wheels, and also it impacts on the signalling system. This contamination impedes the flow of electrical current between the wheel and the rail, and in extreme circumstances means that the signalling system doesn't protect the train.
Our cryogenic railhead cleaning approach works by us firing dry ice pellets at the railhead, aiming at the contamination. The nozzle which is applied out of is designed such that the dry ice pellets come out in a stream of air going at supersonic speed. So they have high kinetic energy when they hit the surface of the rail. They're also very cold, they're about -70 degrees centigrade, so they embrittle the contaminant. Then the high kinetic energy helps to break that down, but also the particles sublime, so they turn back into gas in a tiny fraction of a second, and you get an 800% increase in volume, so you've got lots of little air blasts occurring across the surface of the railhead, which acts to break up and remove the contamination.
Yeah, dry ice is used in a lot of industries for cleaning because it's an environmentally sound form of cleaning. There's no additives to the dry ice, there's no chemicals, it's a food grade product, so it's very, very environmentally safe. It's a recycled product, it's a byproduct of producing, when you produce fertiliser, the brewery industry and biomass power stations. So what we do is we capture the CO2 gas, we then compress it, we turn it into a liquid, and then we turn that liquid into a solid, and we use it in this format for cleaning.
Yeah, so the technology's been developed originally within the lab using very small-scale simulations of the wheel-rail interface, and we've slowly built up through full-scale lab testing to trial the technology on road-to-rail vehicles and a number of other vehicles. But this is a really exciting opportunity for us to test the technology on a train that would normally be in service on actual operational track. That will give us the benefit of trialling at much higher speeds than we've achieved in all of our other work.
Yeah, I think that the dry ice cleaning has got great potential. One of the frustrations is we've done the same kind of activities over the last 20 years, and this gives us something different.
So we found that there's a lot of problems with using sand on a rail, in that at first it works but then it degrades very, very quickly. Now with this process, using the dry ice, we're not layering, we're not putting something on the rail, we're actually cleaning the rail and we're cleaning the wheels. So we're getting rid of the problem that causes the low adhesion.
Dry ice gives us a potential to clean a rail several times a day, 7 days a week, and that stops the contamination building up. I think the drivers will really appreciate that fact, and yes, going forward in 5 or 6 years' time, I'd like to see a lot of service trains actually cleaning their own railhead of leaf contamination.
We're hoping to get the same improvement on the braking as what was achieved on the test track at Long Marsden, but with this scope, this is live on a system, and we've increased the speed from 20 miles an hour up to 40 miles an hour, so we're very excited to see what's going to happen in this application.